Very excited to be here this morning for maybe my first opportunity here with CDCB to talk to you about what we're doing. And I would like to thank Asha for setting the stage for us. And I would like to emphasize that a lot of the work that we're doing at CDCB, we have a fantastic team in-house, but a lot of the work that we do is in collaboration. We work our long historic association with Agile, but also with other groups. So I'm going to get right into it because I have like a lot more slides than I have minutes, and I'm between you guys and lunch, and that's not a great place to be. So I'm going to go fairly quickly through topics, but hopefully we'll have a few minutes for some questions. So I'm going to give an update on where we are with our review of the fertility traits. I'll also discuss our work on single-step genomic evaluation. I know a lot of folks are interested in that. A short update on lameness and foot and claw health, which thankfully the panel did an excellent job of helping lay some groundwork there. Give a sneak peek at the 2025 base change. And then if I have time, I'm going to spend just a couple of minutes reviewing the summer intern research that our three folks worked on while they were with us. And then finally, I'll wrap up with a little bit about enteric methane emissions and some work we're doing in that area. So to get right to it, on our female fertility traits review, the first question, right, is, well, why are we actually taking the time to do a deep dive on these traits and review how everything's working? Well, I think this is a great example of the value of communication and feedback between CDCB and all of our partners in the industry, right? Whether it's our colleagues in the AI companies, it's the producers. Folks came to us and said, hey, some of these DPR evaluations don't really seem to make sense to us. In particular, we see a lot of young bulls whose DPR evaluations change when they add daughter records. And it's not unusual for records to change a little bit when the daughter data come in, but folks were saying these changes seem to be bigger than makes sense to us, right? And in particular, we were overestimating the initial PTAs and they were coming down. So we went to the data to actually take a look at it, right? So let's see what's going on in the data. And so a number of tests have already been done internally, a lot of that work's been done by Taylor McWhorter on the CDCB team. And so we're looking at things like herd by sire effects, and as well as we have adjustment factors in the system that we use to pre-adjust the data before they go into the genetic evaluation. Some of those factors were calculated several years ago and haven't been updated. So we're doing some work on those, right, so that they actually get updated with time. And it was talked about a few minutes ago, actually. I was talking to someone about it. Automation is good. And I know the producer panel talked about it in a sense as well. You don't want to have to look in 15 places to get information. You want to look in one. And one of our challenges has been, as the number of evaluations has grown and the pace of things has increased, well, we sometimes find places in the system where things were done by hand, and now we need to make sure they update themselves. So we're reviewing the raw data, right? To make sure that there's not some sort of shift in the data, either in the number of records or in the information in the records. We're also doing work on the data edits because you want to keep as much data as possible. So you want to make sure that you keep the good data and you don't throw out useful data, but you also don't want to keep suspect data. And as I also mentioned briefly, we're looking at some improvements to the statistical model, things like adding herd by sire effects for all traits that we think will hopefully stabilize the situation here. And I'm going to actually come back in a few minutes to this issue of other ways we think we might improve the the stability of the fertility evaluations. And that is when we get to the single step genomic evaluation. And I know that that sounds very complicated, but I would actually suggest that a single step system is less complicated than our current system. Because in our current system, we take the pedigree and performance information and we estimate traditional genetic evaluations, right? Just like we've been doing since the 1960s. And then we add the genomic information into it in a second step. The point with single step is that you can put all of the information together from the beginning. And I would argue that that's actually simpler, because you're only doing one thing instead of doing two things. So we're investing time and resources into single step evaluations because the multi-step evaluations do not use all of the data that's available. And one of the other concerns, and this goes back to what my brief discussion of the female fertility traits, is that we believe, we in the broad sense, including other folks outside of CDCB, believe that single step models provide more accurate estimates of genetic trends, right? And that's one of the things that we've seen with the fertility traits in particular, is that if you look, we say, oh, we're making this rate of gain, but then folks come back from the field and say, well, that doesn't match with what we see in the actual cow's performance. And there are also advantages for traits such as feed intake, and then looking down the road, say possibly to some measure of methane or greenhouse gas emission. When a trait doesn't have very many records, single step seems to do a better job as well in those calculations. And folks will have to accept this on faith, I guess. The math is easy, relatively speaking. It's really the operational aspect of things that's difficult. And I'm not going to really spend a lot of time on that, but the point is, the hard part's already done in some ways. Now, this work did require, we're working with software that was originally developed by the team at the University of Georgia. So Ignacio Mistel's group and work with Daniela Lorenzo in that group. We have had to make some changes to the software to meet needs that CDCB has that's different than the needs that the researchers have. So we've had to do some work so that we can fit a little more flexible types of models. I won't really talk about sire models here, but one of the differences, for example, is that we need we have different groups of traits for different breeds, right? So the Holstein traits we evaluate aren't identical to the traits we evaluate for Jersey or Ayrshire or Guernsey. And then also we do something called a threshold model analysis for sire cavities, daughter cavities, sire stillbirth, daughter stillbirth. And so we needed to make some changes to the software to support that. The reliability approximations need to be improved. And I'm afraid I don't have time to really talk about that very much right now, but that is something that is important. And Andres Lagara on our team has been working a lot on that. And then, on the CDCB side, not so much the University of Georgia side, we need to make some changes to our data processing pipeline so that every file's in the right place at the right time. So where are we? Because I know a lot of my colleagues in the AI sector have asked, hey, when are you guys going to get single step deployed? Well, I can tell you that we're actively in the testing phase, and we're testing across all trait groups. The last time I talked to Andres about it last week, I think they've got the interval data coming in the way it's supposed to. That's important. And then we're going to do some test runs to check and verify results, right? We discussed earlier the importance of the testing that we do so that results are credible and you're not surprised by things. And in particular, we want to be able to run 2 consecutive runs and make sure that there are no unexpected changes that could be due to the new model. Now I'm going to briefly get into lameness and foot and claw health, and I appreciate the panel discussion about it. so that maybe I don't have to try to explain too much. And I do want to point out that I know for folks in the audience, just so you know that we're aware, here I sort of group hoof health, mobility, and lameness together. We are aware that those are not identical things, right? Mobility is not exactly the same as lameness. And then that whole issue of hoof health is maybe related to lameness and mobility, but it's also its own thing. So we've been involved now for a few years in a project with the folks at University of Minnesota, looking at both. Well, really, the goal is, hey, how do we go out and get data that will drive a genetic evaluation for this? Okay, there we go. And so we sort of have two sources of data in that project. One is mobility scores, which is nice. That's collected using cattle eye systems on a few different farms. And appreciate the discussion, like Skylar sharing their experience with cattle eye, as well as information about hoof lesions that's collected by trimmers when they're on the farm. So these are kind of two different. One is an automated pipeline for the collection of data. The second is sort of using expert knowledge of observations on the farm. And the data are continuing to accumulate. Kristen Gaddis at CDCB, many of you have seen Kristen speak. She's working on this project, doing a fantastic job. So, at this point, we've done internal evaluations to sort of test different trait definitions, see which ones might have higher heritabilities, lower heritabilities, because it's a challenge to figure out, hey, which of these is the best measurement to use in a genetic improvement program? And someone might say, well, if these are all measuring useful things, well, then maybe you need more than one trait. And that's going to get me in trouble because I keep getting told that there's too many traits already. But I want to point out that we have good heritabilities here in the sense that they're in that range anywhere from, say, 10 or 12% up into 20 or 30%. So we can make progress applying genetic selection for these traits. We have also been working with DRMS, and we're also talking with the other DRPCs about getting lesion data that's recorded in the on-farm systems. Because one of the challenges, I don't have time to really go into it today, I'm already running out of time, is that you want to make sure that if you start a data flow, right, you build a pipeline and data start coming in, that those data continue coming in for the long term. And so, hey, cattle eye seems to be a good source of one sort of measurements. It's great to get data from the hoof trimmers, but there's a lot of information that producers record in their on-farm system. So can we also tap into that source of data to build a robust database of information that we can use, right? So, can those data be used? That also lets us build on our existing infrastructure and relationships, and that could also let us turn things around quickly. And so Kristen's been working on this, about 700,000 records. Overall incidence of these lesions is about 8%. Now, obviously, different lesions can have different causes, so you can't necessarily put them all together. But again, a little bit limited on time to go into that. We've got heritabilities of 2 to 6%. It depends a little bit on what kind of statistical model you use. But I would say that this is generally in line with what other researchers have reported using these kind of data from lots of different studies in lots of different countries. So it appears to us that that's certainly a potential source of usable data. So we're going to continue working on that. Our next major step is going to be to get sort of a single phenotype defined, right, a single trait, so that we can move forward towards a potential implementation. Everyone knows we have a base change coming up in April 2025, and so I know folks want to see what the magnitude of the change in traits might be at the base change, and I will show you that in a minute. These slides will be available on the CDCB website. And I'm going to say this even though I suspect that some folks may not really hear me. What I'm going to show you are estimates. When the actual base change values are published in April, they're going to be different from this. But, we wanted to share this because we know this is an important topic for a lot of folks. These are early predictions. They will change. Please don't take a photo of this slide with your phone and then go and make a bunch of decisions off of it, unless you're just kind of a risk taker. So why do we change the base in the first place, right? We get this question. Well, the major reason to change the base is so that you're sort of comparing apples to apples, right? Because there is genetic progress in the population. And if we never change the base, you end up comparing younger animals to older animals, and you're not really comparing them the right way. And, typically when we do a base change, PTAs will go down because we're changing the reference point that we're using to set values to 0. It does not mean that anybody's done anything wrong, right? It's just a mathematical consequence of changing the base. So when we do the 2025 base change, we're going to take the average PTA for cows born in 2020, and we're going to subtract the average PTA for cows born in 2015, right? So the cows born, that will be our new reference group. Changes greater than 0 mean that the younger cows have higher genetic merit, generally, than the older cows. I say generally because we have a couple of traits where the signs are backwards, and so a negative value is, not bad. So these are the estimates, and I know they're a little bit small. They're small numbers on my screen. They're bigger numbers on your screen. We're looking at a lot of folks are going to look first at milk. You're looking at close to an 800-pound change for Holsteins. Jersey and Brown Swiss have the next largest changes. Not much smaller changes for the breeds with fewer animals in the population. The trend for DPR remains unfavorable, and so in this case, all breeds have an unfavorable trend in the base change. I would urge you, as an editorial point, I think if you really want to work on fertility in your herd, you should consider more focus on heifer conception rate and cow conception rate, and maybe a little bit less focus on DPR. So I did compare this to the numbers from the previous base change, from the 2020 base change, and I would say, generally speaking, this is in the same ballpark. So I didn't feel like something changed radically in unexpected ways. So we'll have final estimates out for the 2025 run, I believe. I'm about out of time, so I'm going to sort of skip through the summer intern projects. Please take a minute, if you can, to look in your annual report that you were handed as you came in, because their projects and their hard work are described in that report. And they did very nice work, and my skipping over them is not meant to minimize that, but I also want to respect time. And so I'm going to wrap up here by talking about the work we're doing with the Greener Cattle Initiative on enteric methane emissions, right? So these are the cow, well, we know it's the burps. A lot of folks get confused and think it's the other end of the cow. That's the problem. So what we're doing is we're working in a multi-institutional project here to phenotype about 4,000 lactating cows for their methane emissions, right? So how much are they producing in lactation for this? And there's a few aspects of this. The first is selective breeding. We want to phenotype these lactating cows so that we have a reference population, so we could potentially develop genetic tools. I know somebody's probably going to ask me about the Lactanet tool, and I'm going to put that off. Milk spectrometry. Asha mentioned the mid-infrared milk spectral data. We're also collecting that for these animals. The reason we do that is there's a lot of potential of those spectral data to be used as predictors of other traits. But again, you have to have a training population. I don't really have time to talk about microbiome stuff, but there's a lot of really cool things going on there, right? If you look at the bugs in the rumen, but not just in the rumen, also in the hind gut of the cow. So very fun stuff there. And really at the end of the day, oh, my phone is telling me I'm at time. So I'll wrap this up. Geez, sorry. So we know from our work and the work of other groups that that methane traits are heritable, right? That means they're under at least a partial degree of genetic control. You know, where we're doing data collection both in research herds and in some commercial herds. And you know, genomics is a very important tool working with these traits where they're expensive to measure, so we don't have very many observations, right? Because it can let us get to genomic PTAs with reasonable reliabilities fairly quickly. So if you think about what we did with FeedSaved and RFI, and there are a number of institutions in this project. This is not a CDCB only effort. You know, we're involved with some of the land grants, so with University of Florida, Iowa State, Michigan State, University of Wisconsin, as well as with ARS. And I think this is my last slide. And so what are our preliminary results? Well, when we analyze the data, we have a nice heritability for methane intensity, which is a measure of how much methane is emitted per pound of milk or fat or protein produced. And there's also kind of the idea of this residual methane yield, which is how much methane the cow gives off when you've accounted for everything else, like how much milk she's giving or how much feed she's eaten. So good heritabilities in both cases. This is promising. So as we build up our reference population and establish a pipeline for the ongoing collection of new data, I think we'll maybe next year have some great results to report about progress there. So I'd like to acknowledge all the folks involved in these projects, you know, the dairy producers first and foremost, the DRPCs, the staff at Agile and CDCB. And I think we have a few minutes for questions, Katie.
Yes, you are correct, John. We do have a few minutes for questions. I'm not seeing any in Slido. Are there any from the floor? If not, people are going to let you off easy today.
I'm happy to visit with anybody after this meeting, and I appreciate everyone's time. Thank you.